That right there. That right there is the animal that decided to get sprayed by a skunk. As she's sleeping now, absolutely relaxed, comfy, and happy, right behind me. Take a wild guess what this room smells like right now. All right, how's it going, folks? So, here we are, the end of our first week of our online. If anybody's looking at me and you're saying, wow, Mr. Matthews, your lip looks kind of hurt. That's because my son made his now ninth attempt on my life, and when I went in to say good morning to him, he jumped up and headbutted me in the face. So I'm very proud of him. He's doing well. This is first blood. That's an important day. All right, so why don't we go over the lab that I assigned you guys yesterday, at least in case there are any questions, and obviously in chat. We've had a number of people who do have questions. So we'll go over it and hopefully clarify it a little bit. So make sure that you guys are taking a look up in this area because I'll show you where I'm looking at in order to find the answers. All right, so the blood diseases. Just about everybody has gotten all of the first part done, at least that I've seen or heard. People did their counts, they did their rankings, all that seems good. The first part that people are having issues with is the disease diagnosis, which I talked a little bit about yesterday. But what you want to do here is you want to take your figures and the numbers that you got and the ranks that you got, and then you need to compare them down in this area where it goes through the case history. So, for instance, I'm going to pick out an easy one here. All right, so if we look at the third case history, that's a little bit much. Can I just get this part? No, of course not. Okay, how about just that? There. Case history. Female, Oriental, age 14, has a fever, sore throat, and frequent nosebleeds. Red cells are low in number. White cells are high in number. Blood cell rank is going to have the white blood cells as number 1, the red blood cells as number 2, and the platelets as number 3. The disease diagnosis is leukemia. So if we go back up to our samples and we take a look through here, we are looking for one with a lot of white blood cells, which is figure 5. If you count that one out, you're going to find out that that one has somewhere in the neighborhood of like 18 white blood cells. So we can then identify that figure 5 right over here, right there, this one, the disease diagnosis in that box, we'd write down leukemia because that's what it says right here for the disease diagnosis. And then you need to go back through the other ones and find out which one of these case histories matches up with each one of the blood samples that we've seen. All 6 of them are there. The normal blood is already labeled for you, so the other 5 all match one of these case histories. Yeah, 20. I was eyeballing it. All right. Are there any questions with how you get the diseases? I'll take that as a no. If you're still typing, please feel free to continue. All right, so then let's move on to the questions then, because some people also had an issue with, namely number 8. I had at least 2 people on Schoology message me about it, and then obviously here in the chat. All right, so for the questions on the back, the function should be pretty straightforward. You guys should have looked that up. Remember, on the first page, define each one by its job. Don't bother writing out all the stuff about what it is. All right, when we get down to number 8, it says name a disease that shows too many white blood cells, too few platelets, too few red blood cells, and too many red blood cells. Each one of those is a different disease. So first you want to name the one that has too many white blood cells, which, if you're paying attention, we just did. So hopefully that'll help you out. Then find one of those 5 diseases that has too few platelets. Then another one with too few red blood cells, etc., etc., etc. Now, when you get down to the last two questions, these are going to get a little bit more on using the information. This isn't going to be quite as simple as just looking back through the lab. They want you to kind of explain how this might be happening, what is working or what is not working with that individual, and how we can tell that from their blood. So that's number 9 and 10. Just keep that in mind as you folks go through there. All right. Any other questions on the blood lab? Seems like most people are either done with it or pretty close, and today's not going to be a long day. So you'll still have some time to work on it in our normally allotted hour. On a side note, while people are typing this, watch out. There is one study I saw in particular that's being circulated on a lot of the social media, and it's commenting about how 20% of our coronavirus deaths are coming from young people, and that's a little bit misleading. Not that I want people to think that this is not serious and that you shouldn't take precautions. You absolutely should. But all right, I'll answer this now. Turning in the lab, you have a couple of options. If you opened it with Cami, then you can take it and share it back with E. Matthews at norwichcsd.org. If you opened it with some other program, you could save the file. You can send it to me on Schoology. You can send it to me on email. Or if you printed a copy, you can literally snap a picture of each page and then email those pictures to me. And any of those will work. And if all of that fails, hold on to it. We will be back in school at some point, and then you can just give it to me. All right, so back to that study. The study it's kind of an alarmist study. It's designed to kind of shock people. I believe the purpose of it is probably to try to convince the idiots that are all over the beaches right now partying and basically completely ignoring every warning that has been issued. I think it's designed to kind of hopefully shock them, concern them, and make them start going, oh crap, maybe I should pay attention to this a little bit. We'll see if it works. But one of the issues with it and why the number is misleading is because if you take a look and you actually read through the study, which I've done, the young people demographic that it's using is age 20 to 64. So 44 years of different age people all count into that demographic, with quite a few of them being in the later age categories. And so what they're defining as young adult may not be entirely accurate. Just watch out. When you see articles, when you see things like that, think about that like a scientist. Think about, I want to see the numbers. What do the numbers say? We need evidence. We need to support it. Jesse, if you're having issues sharing it, like I said, save a copy, send it to me on Schoology, or if you need to, you can print a copy. There are lots of ways. We'll take care of it. Don't worry too much. All right, are there any other questions about the lab? I'm assuming not, since I haven't seen anything. So in which case, I want to bring your attention to something a little bit different. Hold on. The cord got wrapped around the end of the chair. There we go. All right. So, what I set up here is basically the next step of the immune system that you guys need to kind of understand at least how it works. So, as you look at it, I drew your cell with all of your bits and bobs in there, and then I also included a COVID-19 virus that's infected it. Now you can see that virus right here attached to the cell membrane. Its genetic material has entered into your cell, and now the cell will start to read that genetic material, and it's going to start making all of these little virus pieces that you see. Some of those virus pieces will actually get themselves incorporated into the cell membrane, kind of like you see over here. Now, up till now, we talked about what T cells and B cells do in order to keep you safe. And namely, we were talking about antibody production from B cells. What I want you guys to realize is that that's good for bacteria, but not for viruses. For viruses, we need something else. the killer T cell. So this is an alternate route that your body will take if the idea of antibodies just aren't working. They're not effectively really doing the job. And what a killer T cell is it's a normal T cell, but now it takes on a new job. And it gets all of these little protein probes along the front. It's going to come up to cells and it's going to start running along their surface, looking for something that shouldn't be there. Things like these little viral pieces. Now, if it finds it, the killer T cell can deliver a message to that diseased or infected cell, and it can basically destroy it. It will make the cell commit suicide before all these little viral pieces are fully built. And without them fully built, the virus is inert. It can't really do anything. And so it can't progress or cause disease. It can't spread any further. So this is your body's defense against viral infection, is to use largely our killer T cells. There are scenarios there, though, where this whole thing goes terribly, terribly bad. Because sometimes your killer T cells identify a healthy part of the cell, not a disease. And when they do, they start to attack and kill those cells, even though they're not dangerous. That is an autoimmune disease. And there's a whole variety of different diseases that are all autoimmunes. Rheumatoid arthritis, irritable bowel syndrome, type 1 diabetes, psoriasis, lupus, multiple sclerosis, celiac disease. It just keeps going. These are all autoimmune diseases, meaning that they're caused by your immune system attacking cells that it shouldn't. And if any of you have these, or you know somebody who does, which is pretty common, psoriasis and IBS are all over the place. Like, it is not terribly unusual. Then now you know what it is. It is the killer T cells incorrectly identifying something that is safe as something that is toxic or dangerous and trying to destroy it. Fun stuff, right? Now, on Monday, we're going to get back to what I'm going to call classes as normal, which means that you could expect probably much closer to a half-hour long presentation instead of these little 15, 20-minute things that we've been doing. We're going to be going over some actual notes. We're going to be, you guys are going to have a worksheet that I'm going to assign to you on Monday. It will be due, as soon as you can get it done, hopefully before the end of the marking period, which is now only 4 weeks away. And the big thing that we're going to talk about on Monday is going to be vaccines. How vaccines work, why they're important. We'll be defining some ideas like herd immunity. If you haven't heard that in some of the videos that I've been sharing or that have been popping up, especially about COVID-19, then that's a really important concept for all of us to understand. It's one of the reasons why people are distancing themselves so much, because we're reduce the number of infections. There's actually a new video that just came out from my favorite channel. I put the link in your Schoology if you want to watch it. The second half of it is flattening the curve. I've literally shown you like 3 videos that already talk about it. But the early part of it is exactly what the COVID-19 virus does, how it affects us, why it's dangerous. So that's worth a watch if you haven't seen anything else about it. Anyone have any questions? I know today's on the short end. We knew it was going to be, but next week we're going to be kicking up into full gear. I'm looking at the comments waiting. It's like you guys are waiting for something to happen. Are you waiting for something to happen? Is there something that happens regularly that people are here to see? Come on, climb up.
Hello.
This is the boy who headbutt me in the mouth this morning and made my lip bleed, didn't you? Uh-huh. Smile for the people. And back to the tongue games. You're a weirdo. You want to show everyone your Pikachu shirt? Here, I'll lift you up.
See my Pikachu star?
Not that high. There you go. All right, this just there. See, it's a squished Pikachu, but there he is. And Pikachu pants too. All right, ready, buddy?
No.
No what? You can still sit here. All right, he's just enjoying seeing himself. All right, guys, listen, y'all take care. I'll see everybody on Monday, and we'll get into our vaccines, and that will be the end of the immune system. After that, Gideon, are you licking your finger? Why?
I like that.
All right, folks.